In this video, we will graph quadratic equations using their essential attributes, really the vertex and the axis of symmetry. So the steps to graph a quadratic equation is first, find the axis of symmetry. Remember that's that vertical line with the equation x equals negative b over 2a. Next, we have enough information to find the vertex. The vertex, remember, is a point where the x value comes from the axis of symmetry. And then to get the y value, we plug in the axis of symmetry, and that's our y value of our vertex, which is why we have that notation here, f of negative b over 2a. In our table, we're going to put the vertex in the middle row and then fill in the values on either side using a calculator, which really just means we're going to plug in and evaluate those points. Then you plot the points on the graph and connect them to make a smooth parabola. So first, we have y equals x squared. First thing we need to do is find the axis of symmetry. So negative b is 0 here, over 2a, which is 1, is equal to 0. That means our axis of symmetry is 0. That also means the x value of my vertex is 0. I now use that 0 to plug in and find the y. Well, 0 squared is 0, so that means the y value of my vertex is also 0. I'm going to have points on either side, so points less than 0, we have negative 1 and negative 2. On the other side of 0, we have positive 1, positive 2. I'm just going in order here. And I'm going to plug in each one of these values to get points. If I plug in negative 2 squared is a positive 4. Negative 1 squared is a positive 1. 1 squared is 1, 2 squared is 4. When I plot those points and connect the parabola, it should look like this. I have my vertex at 0, 0, my point at negative 1, 1, and 1, 1, and then negative 2, positive 4, and positive 2, positive 4. We're also going to talk about domain and range for these quadratic equations. Remember, the domain is the set of all x's. Because this parabola is going to keep getting wider and wider and wider, we have from negative infinity to positive infinity on the x. But on the y values are greater than 0. Now notice that I have that equal to underneath because y can be equal to 0. This quadratic equation is actually very important. I want you to make note of this. This quadratic equation is the parent function for all quadratics. That means it's the simplest parabola that we can make. A vertex of 0, 0, an a value that's equal to 1. This is the simplest parabola we can make. The next example, we're given the equation y equals x squared plus 2x minus 1. We start with the axis of symmetry. B is 2, so negative 2 over 2 times a, which is 1, and we get the axis of symmetry of x equals negative 1. That means the x value of my vertex is negative 1, and when I take that negative 1 and plug it into my equation to find y, I get the y value of negative 2 for my vertex. All right, I need points on either side of negative 1, so the next value less than 1 is negative 2, and then negative 3. On the other side, we have 0 and 1. When I plug in negative 3, I get a positive 2 back. When I plug in negative 2, I get a negative 1. When I plug in 0, I get negative 1. When I plug in 1, I get 2. When I graph that, it looks like this. My vertex of negative 1, negative 2, and then my other 2 points graphed, and I make that smooth parabola through them. My domain is all real numbers from negative infinity to positive infinity. My range is everything greater than -2. Our next example, notice our a value is negative, our b value is -8. When we find that axis of symmetry, we get -4, which means our x value is -4. We plug that in to find our vertex of -1. So we know our vertex is -4, -1. We plug in to find points on either side. So when I plug -6 in for x, I'm going to get -5 back. When I plug in -5 for x, I get -2 back. Notice for -3 it should be -2. Notice how those values match here, because our parabola should be symmetrical. When we have that vertex, those points on either side should match up. Our domain is all real numbers, and this time our range, because our parabola points down, is everything less than or equal to -1. Our next example, when I find that axis of symmetry, our axis of symmetry is +1, which means the x value of my vertex is 1. When I plug 1 back in for x, I get a y value of 3. That means my vertex point is 1, 3. Points on either side of that, so 1 less is 0, and then -1. On the other side, I'd have a +2, +3. Now I'm going to plug in those values. -1 plugged in for x gets me a -5. If I plug in 0, I get 1, 2, I get 1 back, and 3, I get -5 back. So when I plot that graph, it'll look like this. My domain should be all real numbers again, and my range should be y is less than or equal to 3. All right, the next example, I have y equals x squared minus 6x plus 11. Plug in to find my axis of symmetry. Notice how I have that negative of the -6 there, because my b value is a -6. So my axis of symmetry is a +3. And when I plug in the +3 to the function, I get 2 back. So my vertex is 3, 2. Values on either side, I have 2 and 1, and 4 and 5 here. I plug in and get these values. So my parabola looks like this, with my vertex at +3, 2, and points on either side. Remember, it should be symmetrical when you plot those points. Your domain should be all real numbers again, and your range is everything greater than or equal to 2. All right, the next example. When I plug in to find the axis of symmetry, I get 0. So x is equal to 0. That means that my axis of symmetry is actually the y-axis here. So when I plug in 0 to the function, I get -2 back. That means my vertex is 0, -2. So points on either side should be -1, -2, and +1, +2. When I plug in those values for x, I get -6 back from -2 and -3 back from -1. What do we expect to get for +1? We should get -3, because it should be the exact same y value as that direct point on the other side. 2 should give us a -6, so that my parabola looks like this. My vertex at 0, -2, and my symmetrical points on either side of the vertex. Domain should be all real numbers, and the range is everything less than or equal to -2. Our next example, try to see if you can complete this before I do on the video. You could pause here and try it for yourself. we get -2 for our axis of symmetry, which gives me an x value on my vertex of -2. I'm plugging in the -2 for x to find -8 for my y value on the vertex. I need to fill in my table. The values I get here are 0 and -6. On either side I should get -6 and then 0. So my parabola looks like this. My vertex at -2, -8, and my other points plotted. The domain is all real numbers, and the range is everything greater than or equal to -8. The next example, plug in -b over 2a to find your axis of symmetry, which is +2. So x equals 2 is the x value of my vertex. Plug that into x and find the y value is 7. So my vertex point is 2, 7. Points on either side, I should get 0, 3, 1, 6, 3, 6, 4, 3. So my parabola looks like this, with a domain of all real numbers from -infinity to +infinity, and my range is everything smaller than 7. Next example, -b over 2a gives me -1 for my axis of symmetry. When I plug that back in for the y value, I get +1. Values on either side, -3 gives me -3, -2 gives me 0, 0 gives me 0, 1 gives me -3. So my parabola looks like this. My domain is all real numbers, and my range is everything smaller than or equal to 1. Our next example, we have -3x squared minus 18x minus 20. We plug in -b over 2a to get our axis of symmetry, equal to -3. Gives me the x value. When I plug in the -3, everywhere I see an x. Watch out for those negatives here. And that gives me +7 for the y value, which means my vertex is -3, +7. I need to fill in my table with points on either side of my vertex. When I plug in -5, I get -5 back. When I plug in -4, I get +4. -2 gives me 4, -1, -5. So when I plot those points and make that parabola, it's going to look like this. Notice it's pointing downward because my a value is negative. My domain is going to be all real numbers, and my range is everything smaller than or equal to 7. All right, here's our last example. Notice this a value is 1/2. So when I plug in, I have -b, which is -6, over 2 times a, which is 1/2. So that gives me 6 over 1, which is 6. So my axis of symmetry is x equals 6, which gives me that x value for my vertex. When I plug 6 back in, I get -7 for y. So I fill in that table on either side of 6. 4 gives me -5, 5 gives me -6.5. It's okay to get decimals here. 7 will give me a -6.5, and 8 will give me a -5. So my parabola will look like this. Notice it's a little wider. The domain is still all real numbers, and the range is everything greater than or equal to -7.